Hello, this is the video for Unit 2, Lesson 1. We're starting our unit on quadratic functions. The first thing we're looking at is graphing a quadratic function using vertex form. So we know that, or we hope that, most of you recall graphing quadratics from Algebra 1, but there are some important characteristics we want to make sure you guys remember and see before we talk about graphing in vertex form. So we're looking at the function f of x equals x squared, or a quadratic function. That is the parent function. The parent function means that's where we're starting. With any graph, you're starting with this parent function and you're going to be transforming these points. Okay? So it's important to remember the shape of this. The shape should be a parabola. If you draw this like an absolute value, that's not correct. That's not the behavior of this function. Okay? Most of you should be used to seeing this in standard form. Okay? A times x squared plus b times x plus c as the constant. Okay? But like I said, we're going to be doing this in vertex form. Okay? So let's look at what the parent function x squared looks like. Okay, so if you put in 0 for x, you should get 0 for y. You put in 1 for x, you'll get 1 squared is 1. If you do 2 squared, that should be 4. On the other side, we have negative 1. Negative 1 squared is 1. Negative 2 squared is also 4. So we have a curve shape. It's called a parabola. Again, make sure you're graphing it with this curve. That's important to distinguish this between an absolute value function. Because as you'll see, a lot of the other characteristics are the same as absolute values. Okay, so we need to distinguish it using the shape of our graph. All right, so we see that the vertex is 0, 0. The axis of symmetry is the x-coordinate of the vertex. So wherever this is, wherever the vertex is, if it shifts, it's through the x-coordinate of the vertex. In this case, it's through the vertical line x equals 0. The domain is all real numbers, or negative infinity to positive infinity. The range is from 0 to positive infinity. X-intercepts, where does it intersect the x-axis? Okay, and that is at the point 0, 0. Intercepts must be written as a point. Okay, if you write it just as a number, it doesn't really make any sense. Intercepts are points on the graph. Okay, so the y-intercept, conveniently, is also 0, 0. All right, so the rest of this, I want you guys to pause the video and try to see if you can do as a review of from Unit 1. Okay, I'll go ahead and fill these in, but pause the video and try the rest of this section here, and I'll have the answers when you come back. Okay, so for increasing and decreasing, exactly the same as absolute value. Okay, so f of x greater than or equal to 0. Well, that's all real numbers because the lowest point is 0. So that makes this statement true here. All right, the next one, the graph is never below 0. So no part of the domain fits that characteristic. Okay, end behavior, they're both ends are going towards positive infinity. Okay, so that's what we're starting with. Okay, but what we're going to give you are various functions that transform the graph, okay, using vertex form. Okay, this should look similar to absolute value, okay, when we did transformations with absolute value, where A is either the stretch or compression, which changes the shape of the graph. Okay, it's reflected if you see a negative sign, or A is negative, H is, again, this is our horizontal shift. And K is your vertical shift. Okay? Recall that X minus H is part of the formula. So if H is positive, you're going to see X minus a number, which means it's moving to the right. Okay? So let's look at this first one. F of X equals X minus 5 quantity squared plus 4. Okay? So what this is actually doing, the way this is set up, is this is just telling us where the new vertex is. Okay? This is telling us that the graph is shifting to the right by 5 units and up 4. Okay? So if the vertex moves right 5 and up 4, the new vertex is at the point 5, 4. Okay? If the whole graph moves up, that's going to change the range. So the new y-coordinate of the vertex is 4. So that means the range of this function is going to be 4 to positive infinity. Okay? We hope that you can do that without graphing this function. Okay? If you have to graph it to answer for now, that's okay. But eventually, we want you to get to the point where you can figure that out without having to graph it. Okay? So if you start with the parent function here, these 5 points that we did at the beginning, and you translate them like you did in geometry, you'll get the new graph. So each point goes over 5 and up 4. So now we're here. This next point, over 5, up 4. The next point, or the negative 1, 1, goes from 3, goes to 4, 5. These next ones are off the graph, okay? So if we take the point negative 2, 4, that's going to be at 3, 8. So that's going to be about up here. And the point 2, 4 is going to be at 7, 8. So this is our new graph. So all we're doing is we're taking the form that we're given, using what we learned in geometry about translations, and hopefully what you remember from Unit 1 about absolute values, and shifting those and finding the new points. Okay? When we ask you these in classwork, you're going to need to tell us things like, when's it increasing, when's it decreasing, when is it above or below, f of x equals 0, that kind of thing. But for now, let's just focus on the graphing. Okay? Go ahead and try the next one. Pause the video and try the next one, and I'll have the answer when you come back. All right. So the function is x plus 5 quantity squared minus 4. So remember, now we're moving left 5 and down 4. Okay, so from the original or parent function, which are the black dots, you're going to the green dots and that new parabola. Okay? These are all translations. These are just shifts. Okay? Left, right, up, and down. Okay? So now what we're going to do is go to the next page and take a look at if we have a reflection or if we have a stretch or a compression. Okay? So let's look at this first one. F of x equals negative 2 times x squared plus 4. All right, so let's look at what's happening to this graph first. Okay, we have a negative, so that means it's being reflected. Okay, again, another way to think about this is that it's opening down. Okay, we're stretching it by 2. And we're moving it up 4. All right. So we can still find the vertex the same way. You can just look at the horizontal shifts. or excuse me, horizontal, any of the horizontal or vertical shifts. Okay, so there's no horizontal shift here, just vertical, so it's moving up 4. So the new vertex is going to be 0, 4. Okay, width, that's just saying, are we stretching it or are we compressing it? So we're stretching it by 2. So we have that here. All right, max or min, okay? This you might need to graph to see. But remember, if we're reflecting it, that means the graph is going to be upside down. So instead of having a minimum, like the parent function did, now it's going to have a maximum wherever the vertex is. And we're looking at the y value. Okay, max or min relates to y value and the range. Okay, so the max is going to be y equals 4 when x equals 0. Okay. So let's graph this. Again, you've got your parent function points here. First, I'm going to do the reflection and the stretch. Okay? So what these do is we're multiplying by the y values of each point. Okay? So take each point and multiply by -2. Well, this one is 0, 0. That's not going anywhere. But I'm drawing the red for this first step. The red is my multiplication. Okay? Then I take the point 1, 1. I'm going to multiply that by -2. Okay? I'm going to multiply the next point by -2. That's going to go down to -8. There. And then this point here, when x is -2, y is 4. That's also going down to -2. -8. Okay. Oh, I skipped one. Sorry about that. So the -1 point, again, since this is a symmetric function, okay, there's this line of symmetry here. All the points should just reflect over that line. Okay, so we're not done yet because we've just done the stretching and the reflection. Okay. Now I'm going to shift all of these points up 4. If there was a horizontal shift, you could do that at the same time. So I'm going to do the horizontal shift or the vertical shift in green. So each point's getting moved up 4. This middle point up 4. This point here to the right up 4. This point down here. Oh wait, that should be, that was 7. Here and here. Okay, so if I go up 4, that goes from 8 to 7, 6, 5, 4. There. So from 8, 7, 6, 5, 4. This is my new function in green. So the red was the stretch and reflection. You could also do the compression. And then I did my translation. Okay, so in a way, it's like order of operations. You want to multiply before you add, so you make sure you get the points in the right spot. You can do this in steps. Some of you might be able to do this all at once. That's great. I want to break this down in steps so everybody can see what's happening. All right, so we start with the black points, or the parent function. The red points are when we multiplied by the y. And then the green is when we did our shift. Okay, so try that same method with the next one. All right, this next function, f of x equals 1/2 times x minus 4 quantity squared. Pause the video and try that. I'll have the answer when you come back. All right, so this green graph is where you should end up. The vertex is at 4, 0. We compressed it by 1/2. It's a minimum because we didn't reflect it, so there's a minimum at y equals 0, and the whole graph moved to the right 4 units. Okay, you see my black points is a parent function, the red points is the multiplication, and the green is the shift, is the final function where we're ending up. Okay, so let's look and see what happens if we give you a description. So we give you a description and we want you to write the equation. Okay, so very similar to how we did absolute value. You'll need to go back and forth. You'll need to go from a graph to the equation. You'll need to go from a description to an equation to a description, and so on. You'll need to be able to do all of those. Okay, so we're going to use these clues to write the equation. Right? You should always start with f of x. So the range is -infinity to -2. All right, so remember, if we're starting at -infinity, it's coming from the bottom, which means this function is opening down. So if this function is opening down, we're going to have a negative sign out in front. Okay, now I'm telling you that the width is the same as the parent function. Okay, which means there's no other number in front of these parentheses. There's no compression, there's no stretch. Okay, so now I'm going to do my shifts. So I'm telling you that the axis of symmetry is x equals 3. Well, if the parent function, the axis of symmetry is x equals 0, that means we shifted the graph to the right 3 units. So that means I'm going to do x minus 3. Okay? And you also see here the range goes to -2. That's my maximum y value, which is the vertex. So that means the vertex moved from 0 to -2, which means it went down 2. So I subtract 2 here. So this is my function based on this description. Okay, look at the next set of clues and see if you can figure out that equation. Okay? All right, so you should get f of x equals 3 times x minus 3 quantity squared plus 2. Okay, so I threw these at you. We didn't talk about these when we were graphing the transformations just at the beginning. So remember, if it's increasing from 3 to infinity, this isn't 3, but it's just an example. Okay, that means I'm going up from the vertex to infinity. Okay, and remember, increasing is the x values. Okay, so if it's decreasing from left to right until 3, that means the x coordinate of the vertex is 3. If the range is 2 to infinity, that means it's opening up. Well, these are both clues that it's opening up. All right, and the range is 2 to infinity, so that means the y coordinate of the vertex is 2. Okay, so that's writing the equation of the function in vertex form given a description. So as always, make notes. Anything you had questions about, bring those to class, and we will see you then.